Okay, lesson 63 talks about the unit circle and then also radian measures. So we're going to start with some vocab. A unit circle means that we have a circle with a radius of 1 and it's centered at the origin. Our angles can be measured in degrees, which is common for us so far, and we're going to introduce something called a radian. A radian is an angle measurement based off of the arc length. So arc length is part of your circle, the part of the circumference. And 1 radian is equivalent, or you get 1 radian when your arc length and your radius are the exact same. Okay. One more thing. In a circle, you have 360 degrees, or we have 2 pi radians in a, that should say unit circle. So if you think about circumference is 2 pi r. Well, in a unit circle, our radius is 1, so our circumference would be 2 pi. Okay, converting angle measurements. We can go from degrees to radians. We can also go from radians to degrees using these two formulas. So you're either going to multiply by pi over 180 or 180 over pi. Okay, so I want to convert negative 30 degrees into radians. So you're going to take your angle measurement times pi radians over 180. Multiply fractions straight across, you get a negative 30 pi over 180, and you can simplify your 30 over 180 and get negative pi 6 radians. Now I want to go from 3 pi fourths radians into degrees. We're going to take our 3 pi fourths times 180 over pi. Again, your pi's will cancel, but then you're going to multiply straight across. So you get 540 divided by 4. This is a 135 degree angle. You guys go ahead and convert 45 degrees into radians. All right, here we go. Since a unit circle is centered at the origin and it has a radius of 1, we can use those special right triangles to find the coordinate point of our special angles. So if we go back to a couple days ago, our 30, 60, 90 triangles, our short leg is always x, our hypotenuse is always twice that, and our long leg is always our short leg times square root of 3. 45, 45, 90 is isosceles, so your two legs are x, your hypotenuse is times root 2. So I'm going to sketch part of a unit circle. This is just the beginning. We have 0 degrees, we have 90 degrees. In between we have 30, 45 is straight down the middle of 0 and 90, and then we have 60. We said a unit circle has a radius of 1, so this length is 1, this length is 1. All of these radii are 1. So I dashed in this 30, 60, 90 triangle right here. And if I bring it down here, I know my hypotenuse is 1 unit. My short leg is half of that. So this short leg would be a half. And then I take my short leg times the square root of 3 to get the long leg. So half times square root of 3 gives me square root of 3 over 2. Since this is on a coordinate plane, this is my x value, so root 3 over 2. This is my y value, so a half. Okay, take your 45, 45, 90 triangle. Envision there being a triangle right here. It would look like this. Again, our radius is 1. Well, in order to get to our side, we would have to divide by square root of 2. Get rid of that radical by multiplying by root 2 over root 2. You get square root of 2 over 2. That is your other leg as well. Again, a coordinate point would be an x, comma, y. X is horizontal, y is vertical. So our x coordinate is root 2 over 2. Our y coordinate is root 2 over 2. Last triangle would be the 60 degree triangle. It's still a 30, 60, 90 triangle. Our hypotenuse is still 1. Our short leg is a half times square root of 3 to get our long leg. This time our x value is a half and our y value is root 3 over 2. So I'm going to use these 3 coordinate points and I'm going to put them back on our unit circle. So here we said our 30 degree angle had a coordinate point of root 3 over 2 comma a half. 45 was root 2 over 2 comma root 2 over 2. And our 60 degree angle had a coordinate point of half comma root 3 over 2. Our goal is to fill in the remaining 3 quadrants, which we'll get to in a minute. But before we do that, I also want to look at trig our trig functions in the unit circle. So we're going to take this 30, 60, 90 triangle. If I find the sine of my angle, we talked about that being y over r. Okay, the other day we talked about that being y over r, or opposite over our hypotenuse. Well, our y value is a half. So we would have half over our hypotenuse, or our radius, which is 1. We all know half divided by 1 is a half. Okay, notice that's also just the y value. Let's look at the cosine. Cosine we said was x over r. So we're looking at root 3 over 2, all divided by 1. Well, again, that's root 3 over 2, which is our x value. So this is a huge statement. Our x comma y coordinate point will always be cosine comma sine. That x value will always be the cosine of 30 degrees. That y value will always be the sine of 30 degrees. So when you go to make your unit circle, you'll want to keep that in mind. To help us fill out the remaining 3 quadrants, we're going to remember the signs of each quadrant. So right now, I've given you enough information for this first quadrant. Both our x and our y were positive. When you move to quadrant 2, remember your x becomes negative. Quadrant 3, both values are negative. Quadrant 4, your y is negative. So you're going to use this sign chart to help you fill in the remaining coordinate points of your unit circle. The last thing I want to share with you, and there's examples in your book, we talked about arc length at the very beginning of the video. Arc length is part of your, or an arc itself is part of your circumference. So it's a piece, or it's a portion, a fraction of your circumference. They use the notation or the letter S to define or to symbolize arc length. There's a formula. To get your arc length, you're going to take your radius times your degree. But the key thing is your degree must be measured in radians. So anytime that asks for your arc length, you're going to use this formula. You'll be given your radius and your angle, and you can multiply those to get your arc length. Okay, sometimes you might have to solve for your radius, but you'll always be given a couple pieces of information to solve for one of the unknown variables.